Section 7.3 Interactive Assignment. Objective 1. Suppose a sample of O-rings was obtained and the wall thickness in inches of each was recorded. We want to use a normal probability plot to assess whether the sample data could have come from a population that is normally distributed. So here's our data. Okay, so we're going to go ahead and open this up into StatCrunch because we want to be able to use that correlation coefficient of the normal probability plot and determine whether it is reasonable to conclude that the population is normally distributed. So we're going to go ahead and open this data up into StatCrunch. And you can see that here's column 1, variable 1, and we can see that here's all our data, and we can see that we have 16 observed data. So we're going to go to graph, and then what we're going to do is we're going to go ahead and go to QQplot. We're going to select the column. We're going to make sure that we have the correlation to statistic selected, in addition to normal quantiles on the y-axis. So we're going to select compute. So here we can see that our data is kind of around this line here. So the correlation is 0.975. Now we know the correlation is 0.975, okay? And then we also want to be able to find the critical value. Now remember that we have 16 values, okay? So if we take a look at our data here, all right, we know that the sample size n is equal to 16. So since we know n is equal to 16, we're going to come over here to where it says click here to view the table of critical values. So we're going to select that. Now we need to look for the sample size when we find 16. So if we look up here, here's the sample size of 16, and the critical value that's associated with that is 0.941. So let's go ahead and put that in there. So the critical value is 0.941. Okay, so now what we want to do is we want to compare this critical value with the correlation coefficient. Now let's go back to our graph. We know that our graph has the correlation is 0.975 at the top here. So we have 0.975 represents the correlation value, and we know the critical value is 0.941. Now, since this correlation value is greater than the critical value, then we're going to say that the data are from an approximately normal population. So let's go ahead and put in our information here. So we need to answer our question. Okay, well, we know that yes, there is a correlation. Okay, so we're looking at both the yeses because we're going to exclude the ones that say no. So the correlation between the expected z-scores and observed data was the following. Well, we know again that the value of that is 0.975. Okay, now we want to say that it creates a normal population, so we cannot say it's going to be for C. We're going to look at part B. So we have, again, we're going to put in the correlation value, which is 0.975, and exceeds the critical value, which was 0.941, and then we're going to check our answer, and there is our result.